Hello, welcome to section 5.1, which deals with systems of linear equations by graphing, solving them by graphing. So basically, we're going to determine if an ordered pair is a solution to a system of equations. We're going to solve it by graphing. We're going to figure out how many different types of numbers of solutions are possible, and then possibly some applications, okay? So first of all, what is a system of linear equations? Okay, so that's just like a fancy way of saying, oh, there's equations, like maybe two or more algebraic equations. Okay, that's what that means. It's not like crazy. So usually right now in this course, we're going to most likely deal with just two. So first of all, what is a solution to this system? So here's an example. This is a system of equations right here. These two, it usually has a little curly brace next to it. And the solutions, are the values of the variables that make it true. So let's do an example here. So we're given this system of equations, x minus y is equal to -1 and 2x minus y is equal to -5. So remember that this is xy, this is a point xy. So to determine if it's a solution, you plug it into both, and if it's true, then it's a solution. If it's false, it's not. So plugging it into to this one, right? I'm going to do -2 minus -1 is equal to -1. So we're asking if that's true. -2 plus 1, that is -1. So yes, this point fits half of it. But now we got to plug it into the second equation. Okay, so fine. So 2 times x is -2 minus a -1. Is that equal to -5? Okay, so this becomes -4. This becomes +1. So does -3 equal -5? No, it does not. So this is not a solution, okay? So A is no, because it has to fit both. It has to fit both equations true for this case. So here B, let's try this again. So the first equation, we have -4 minus -3, and we want to know does that equal -1. Okay, so we get -4 plus 3 equal to -1, and yes, -4 plus 3 is -1 today. So yes, that part is true, but make sure we have to try both. They both have to be true. Okay, so 2 times x minus y, which is -3, is that equal to -5? So -8 plus 3, is that equal to -5? And it is. So -5 equals -5. So yeah, so actually, yeah. So -4, -3 is a solution to this system. Okay. All right, let's do another example. Let's determine if these points are a solution to the system. So first we're going to do A. We'll do A first and then B. So for A, remember we're going to have equation. We'll just label this equation 1 and the other one equation 2, just to make sure that we have our notes organized, right? So for the first one, I'll just rewrite it. You don't have to rewrite everything, but I just like to, just so there's no confusion. And then the second one would be x plus 2y is equal to -5. So we're plugging it in. So first we're doing A. So 3 times 1 plus -3, is that equal to 0? Question. Well, 3 minus 3, right? That is equal to 0. So 0 is equal to 0. So, okay, if it's one of them, let's try the second equation. X is 1 plus 2 times y is -3, and is that equal to -5? That's what we're asking, okay? So 1 plus, this is a 1, looks like a weird L, minus 6, is that equal to -5? And 1 plus -6, same as 1 minus 6, is yes. So that's -5. Great. So this is a solution. A is a solution. So 1 comma -3 is a solution. And then if we were to try the second one, let's use a different color just for fun. So here we have x and y. So that's B. We're doing letter B now. So let's try equation 1. Remember, equation 1 is 3x plus 2y is equal to 0. And equation 2 is x plus 2y is equal to negative 5. Okay, fine. And we're testing the point 0, 0. So 3 times 0 plus 0 is equal to 0. Is that equal to 0? No, we're not here. It would be here. Yes, so 0 is equal to 0, so that's true. So let's plug it in the second one, and I'm looking, it's not looking good. 2 times 0 is equal to negative 5, so 0 does not equal negative 5, so not a solution. So that's one way to test if it's a solution or not. So, but if you know a little bit of theory, there's something cool that you can figure out. Okay, so let's show first the different types of lines. Okay, so there's 3 possibilities if you have 2 lines, right? A system of 2 equations. So there's either both lines intersect, like they cross. So let's say this is one of the lines and here's the second one, and they both intersect at that point. If they do, that's one solution. Okay, so if they have one single solution, that's what it is. Or let's see so that's a very common one. So one solution, which is just it has a solution and it's some kind of, some kind of point, coordinate point. Okay, so then here, the 2 lines are not touching at all. They're actually parallel, they have, and you could probably check that if they have the same rise over run. So then you remember parallel lines have the same slope. Okay, so if they do they ever cross? Because remember that the solution of 2 lines is where they intersect or they touch. So since they don't have any points in common, there's no solution. Okay, they never cross or they never touch. Now, what if the equations are basically the same equation, but they're just multiplied by a different number or something? So you can imagine that the lines are kind of maybe on top of each other, right? So you can kind of think of it like this. Okay, you have one line and then you have the other. And since they're crossing at every single point possible is a solution. So the way that we say infinitely many solutions. Or you can, infinitely many. Okay, so those are the 3 possibilities, okay? So how do we solve it? By graphing. So let's say you have two equations and you want to graph and you want to find the answer. So first thing that you do is you graph the first equation. Then you would graph the second equation and see whether they either intersect, parallel, or are the same, okay? So let's go ahead and do one because we love this. Okay, so let's say we have here 2x plus y. Let me just, 2x plus y is equal to 7. And x minus 2y is equal to 6. So I'm going to go ahead and graph. So let me first, but before I do that, I need to have both equations into y equal mx plus form. That's just easier to graph. I'm going to do it that way. You could do it using a tape. You could do it a different way, but I think this is easier because if I just have y equals negative 2x plus 7. And so why don't I go ahead and do that for the second one? I have x minus 2y is equal to 6. So then minus x. Okay, I get negative 2y is equal to negative x plus 6. Divide everything by negative 2. I get y is equal to, so this is negative x over negative 2 is going to be 1/2 x. Okay, and then positive 6 over negative 2 is going to be negative 3. Okay, so we have these 2 lines now in a nice order. So let's go ahead and draw our little, coordinate plane here. Yeah. Okay, so let's say here, and then I'm going to go 2, 3, 4, 5. I don't like that one. That one's not too. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'll do 10 on this side. Or however many, and then here. Okay, so let's graph the first one. So the first one has a b, remember y equal mx plus b form. That means that the slope is -2/1. And the y-intercept is +7. So that means here at 1, 2, 3, 4, 5, 6, 7, that's my starting point, right? And then what does the slope tell me? -2/1 means to go down 2 and to the right 1. Okay, fine. So I'm going to go down 2. So 1, 2, and then to the right 1. So to the right 1 over here. So then you can do this again. Down 2, 1, 2, to the right 1, right? Okay, you can do this like a couple of times, but let's just go ahead and leave it like that. Okay. Oh, sorry. I don't like how that's... Let's see. No, actually, let's just see if I can go down 2/1. Just one more. 2/1. Okay. Okay, so that's... there we go. This 2x plus y is equal to 7, or y is equal to -2x plus 7. Okay, and let's do the next one. So we have y is equal to 1/2 x plus 3, which tells us that the slope is +1/2 and the y-intercept is 3. 1, 2, 3, negative right there. And I go up 1/2, up 1/2, up 1/2. Okay, so you can kind of see that's where they connect, right? At that point here. So what point is this? Oh, this was -3, by the way. What point is this here? This is the point 4, -1. So what does that mean if you have a point, graphically? If you found it graphically, that basically means that this point, if I was to plug it into equations 1 and 2, I would get true statements. Okay, so that's the solution. Okay, let's do another one. This one's nice because they're already in the right point. So let's see here. So this will be 1, and this one will be 2. So then for the first one, it's already there. So let me go ahead and draw the little graph. Oh, 1, 2, 3, 4, 5, 6, 7. I don't know. 2, 3, 6, 7. 2, 3, 4, 5, 6, 7. Okay, and then 7 down, I guess. Oh, I don't like those last two. Sorry. Okay, so for the first one, the starting point is what? So for the first one, it's y equal to x plus 1. So the slope is 2/1, right? And b is 1, so that means it starts at 1, okay? And then it's both positive, so it goes up and to the right. So it goes up 2/1, up 2/1, like that, right? And so on. It could also go down 2 and to the left 1, because that would be negative times a negative is a positive. I mean, negative divided by a negative is a positive. So there you go. Okay, and then let's go ahead and do this one. 4x, y is equal to 4x minus 1. This is an x. That means the slope is 4. Why am I drawing weird? Okay, the slope is 4, and the y-intercept is -1. So drawing a point here at -1, that means I'm going to go up 4 and to the right 1. So then from here, I'm going to go 1, 2, 3, 4, and then to the right 1. So that's right here. Then again, 1, 2, 3, 4, and then to the right 1. So that's like right here. So you have a line that kind of goes through here. Sorry, that's not the best drawing. I really did. Okay, there you go. Okay, sorry about that. Okay, and then, so what's my point here? Right here, right? That's where they meet. That's your solution. So finally, what's the value of x and y at this point? That's +y and then +3. So your solution is 1, 3. All right. Let's see what else we can do. So let's try this one. We have a y equals 6 and 2x plus 3y is equal to 12. So, okay, so let's go ahead and do the same thing. So we have the first one, we'll let y equal 6. That's a nice one. That's nice and easy to draw, right? That's just a straight line going horizontally, right? Let me go ahead and draw this. So here, I'm gonna do. Oh my goodness, I don't like that. Okay, let's try this again. Okay. Thankful this isn't an art class, but still. Okay. Well, you know, you got to try to keep them equidistant or else your numbers might be off. So that's the only thing, like, you might not like about graphing is because you have to be very exact. And if you're not exact, then you might get the wrong answer. So it's a little bit. So, okay, so y equals 6, right? That's just a horizontal line crossing through 6. So we have 1, 2, 3, 4, 5, 6. And it's just going to go straight across. Right? It has no slope. Slope is 0. So this is y equals 6. The next one, we need to solve for y. And then we'll go ahead and do, you know, do what we do. So taking 2x for both sides, I have 3y is equal to negative 2x plus 12. Divide by 3, I get y is equal to negative 2/3 x plus 4. Okay, fine. So m is negative 2/3, and then the b is 4. So just in case you guys, I didn't write this down here, but I should anyway, just to be super thorough. Okay, so my starting point is 4. 1, 2, 3, 4. Okay, there. And then I can go down 2 and to the right 3. Or I could do, see it this way, which would be up 2 and to the left 3. Now, because you see how the blue line is above this dot, it makes sense to use this one, this version of it. So I'm going to go up 2 and then over 1, 2, 3, right? And that's the dot. So it's going to be up 2 over 3, okay, in the left direction. And that's our line. I mean, could you have done another? Yes, we could have done another one, but we didn't really need to because that was the answer, right? It crossed at that point. So what is the final answer? So, okay, so that's x is negative 3. And what's the y value? The y value is 6. So, of course, y is 6. And then if you plug this into here, you would get 12. So that's your solution. Okay, let's see. I'm pretty sure you guys can do, let's go ahead and try this one. That's an x equals 1. Okay, so let's draw our coordinate plane here. Okay, and then we have x equals 4. Yeah, what does that look like? Remember what that is? That means that the slope is undefined. Okay, and it's a vertical line going straight up and down. And it has, does it have a y-axis, a y-intercept? It doesn't, right? Because why wouldn't it have a y-intercept? Remember that vertical lines are parallel to the y-axis. This is just like something we should start kind of remembering. Are parallel to y-axis, so it will never cross unless the actual equation is x equals 0, because that actually describes the y-axis. Okay, so 1, 2, 3, 4, and it's just going to be a straight line, straight vertical line through x equals 4. Okay, because that's what that is here. Okay, so then for the second one, we have 3x minus 2y is equal to 24. By now, we should be experts at solving for y. So we get negative 2y is equal to negative 3x plus 24. Divide everything by negative 2, and what do we get? We get y is equal to 3/2 x minus 12. So that means we have, that means we need to draw 12 little tick marks. That's fine. So that's going to be a little bit longer than I want. Let me try to do it in black, just for consistency. And I think I'm also going to erase. Oh no. Oh no. Let's see here. That doesn't. Berg. Okay, so sorry about that. Oh my gosh. Oh my gosh. Everything is happening right now. Okay. Here's where the x-axis was. And it's straight. I'm making it longer because it has an intercept at -12, so I have to go 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's all the way down here, -12, right? That's the B. And then the M is +3/2. So it goes up 3 and over 2, okay? And actually, I might also have to extend this blue line. So let's just do that. Okay, so up 3/2. So up 3, so 1, 2, 3. And then over 2, 1, 2. Make a dot just in case. I'm going to write that. Okay, up 3, 1, 2, 3. Then over 2, 1, 2. And there it is. Okay, so, okay, yeah. So then that's your line. And we've also very conveniently found the intersection. And that's our answer, yeah? Right here. That's our answer. So let's see here. So x, of course, is 4. Then what is y? So 2, 3, 4, 5. So -6, yeah? So that's your answer, 4, -6. So not too bad. Not too bad, people. Okay, so I think we have that. And then again, here are the different lines and what they're called. We have intersecting, where they intersect at one point. Parallel, they never touch. So one solution. This is 0 or no solution. No solution. And then this one is infinitely many solutions. Infinitely many solutions. And you can see that in this cute little table. Okay, so if they have the different slopes, they're intersecting. And we only have one solution, 1 point, right here. You know, not exactly there, but, you know, that's the example. And then if the slopes are the same, but the intercepts are different, if the slopes are exactly the same and they both cross the y-axis at different places, they're parallel and you have no solutions. And then finally, if you have the same slope, same intercept, this is called a coincident or coinciding lines, right? They're on top of each other. Okay, infinitely many times. Okay, so that leads us to another definition. Well, first let's talk about that. Coincident lines basically have the same slope and the same y-intercept because technically they're the same line. Okay, so there's that. Okay, and then let's talk about consistent and inconsistent systems. Okay, so consistent system is a system of equations with at least one solution, and then inconsistent would be no solution. All right, and then independent versus dependent. Two equations are independent if they have different solutions, and two equations are dependent if all the solutions for one equation are also solutions of the other equation. Okay? All right, so without graphing, can we determine the number of solutions and then classify the system of equations? Sure, so we get to use that little table thing again. So this one already I can see what slope is. M is 3. The y-intercept is -1. Okay, this is a -1. So then for this one, let's go ahead and solve for y. So we have 6x minus 2y is equal to 12, minus 6x minus 6x. We get -2y is equal to -6x plus 12. Then divide by -2. We get y is equal to 3x minus 6. Okay, so the slope is 3 for this one, but the y-intercept is -6. So you have same slope, different intercepts. So what that means is that you have a pair of parallel lines, right? They do not have a solution. Okay, so they have no solution. They are inconsistent. This is an inconsistent system. Okay. All right. Let's do another one just for funsies. So we have y is equal to negative 2x minus 4. That's already there. So this slope for this is negative 2. The y-intercept is negative 4. So then we have 4x plus 2y is equal to 9. So let's go ahead and put that in y equal mx plus b form, yeah? So subtract 4x from both sides. You get 2y is equal to negative 4x plus 9. Divide everything by 2. Y is equal to negative 2x plus 9 over 2. 9 halves. We'll just leave it like that. We're not graphing it, right? Sorry, this isn't equal. So the slope here is negative 2, but the y-intercept is 9 halves, which is, 4.5. So they're different. So same slope, different intercept. Again, these are parallel lines. And it's an inconsistent system because they never cross. Okay. So you can kind of see here, you can determine the number of solutions and then classify by solving it for y. Writing into y equal mx plus b form and then comparing the slopes and the intercepts. So I guess we'll do another problem here. So we have, if I subtract 2x from both sides, I will get y is equal to negative 2x minus 3, right? So that's basically, I just did this, okay? For the first one, and then for this one, I'm going to write this one out. X minus 5y is equal to 5. Subtract x from both sides, then you get minus 5y is equal to negative x plus 5, and then divide everything by negative 5. We get y is equal to 1/5 x minus 1. So for those of you that are saying, hey, how did you get from there to this, from here to here, I'm just going to take an intermediate step. So this is thinking you can separate these two fractions, right? Negative 5. So then this cancels out. So you get x over 5 plus a negative 1, which is just minus 1. But what's x over 5? Remember? So x over 5 is equivalent to 1/5 x. Okay? Anyways, that's for whoever, So these guys have different slopes and different, they have different slopes and, obviously they have different intercepts. So these are intersecting lines, okay? So they has one solution. Intersecting lines. One solution. One solution. And what kind of system is that? It's consistent. Okay. All right. Should we do another one? I think you guys kind of got it, or hopefully you do. So let's see what else we have here. We're going to do an application problem. So first, let's go ahead and describe what we need to do. So obviously we need to read the problem. We need to figure out what they're asking, name it, choose variables to represent that, translate into a system of equations, solve it properly, and then check the answer and see if it makes sense. That's the same thing. I don't know why I did that. Who knows? Okay, so let's do one here. Sandra is making 10 quarts of punch from fruit juice and club soda. The number of quarts of fruit juice is 4 times the number of quarts of club soda. Okay, fine. So she has fruit juice here. I'm just going to draw a little picture. This is like some juice. Okay, and then she's going to add the soda, the club soda. And then that's going to equal 10 quarts of something, right? This is going to be the punch, right? So what that means is if, let's say, let X be quarts of fruit juice. I can't spell. Something is, okay. Okay, and then Y, we'll let that be club soda, amount of club soda, number of quarts, or you can write quantity of club soda. Okay, so together, that's going to be 10 quarts, right? She's going to add the fruit juice and the club soda, and together it's going to be 10. But what else? So that's one of the equations. The next one is the number of quarts of fruit juice is 4 times the number of quarts of club soda. So the number of quarts of fruit juice is 4 times the number of quarts of club soda, okay? So that's your 2 equations. So you can graph this. That's what we're doing here. So we have equation 1 and equation 2. Okay, so let's change the colors for fun. Okay, so we have equation 1. We have, well, let's go ahead and solve for y. I don't know where my graph is going to go. I guess I'll just get rid of this here. So we have y is equal to negative x plus 10. So that's 1. And then for the second equation, all we need to do is solve for y. So we have y is equal to x over 4. But what does that look like in terms of, slope? Remember, that's, I don't know why I wrote y 1/4 x. Okay, so now we have the 2 equations. So let's go ahead and draw and then find the graph and the point of intersection like we've been doing. Okay, so here we go. Oh, the y-intercept is 10 here, and the slope, -1, y-intercept is 10. So we need to have, we need to make sure that we, label our graph appropriately. 1, 2, 3, 5, 6, 7, 8, 9, 10, and then an extra one, then the same size. So then here we're starting at 10. So I'm going to go ahead and use colors. So B is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and the slope is -1. So what does that mean? When you have the slope of -1, you can write it over 1. So that means down 1 and to the right 1. So down 1 over 1, down 1 over 1, and so on. So let's see. Okay, so it's going to go through here. Okay. And then 1/4 x, it's basically, there's no, see how there's no b? So that means that it goes through the origin. Okay, when there's nothing there, we can write a 0 and say, oh, b is 0. Okay, so m is 1/4. So you start here at the origin. You're going to go up 1 over 4. Up 1. So up 1 over 4. You're going to go up 1 and then over 4 over here. Then you're going to go up 1 and then over 4. So it's going to be like right here. So then you draw your line through that. And wherever they intersect, that's it. So this is where the point of intersection is. Now, this is interesting because we're like, okay, well, it looks kind of like here. And it looks like maybe it goes, over here maybe. So we have here, so like 9.5 or 8.5. 8. So we have here, sorry. So x looks like 8.5. I don't know what that is. 8.5. Let me erase it. And y is 2. But that doesn't make sense. That doesn't add together. So what did I do wrong? It looks like I guessed the position wrong, right? So maybe I drew my graph incorrectly. So this leads us to a good, so this is the solution, 8, 2. And you know how we know? Because we could plug it in to check. 8 plus 2 is 10, and also 8 is equal to 4 times 2. So yeah, so the actual answer is 8, 2. So see how I graphed it weird? So if I'm in a rush and I'm graphing is not like the best way to solve a system of equations. Okay, but that is an option, but it's not the best way. So stay tuned for how to do that in the next few sections. Okay, so that's it for 5.1. There's your super fun homework. Good luck, and I will see you on the next video.